Bismillahirrahmanirrahim. Assalamu alaikum, dear students. I am Arif and I welcome you all in today's session. To access the notebook for today's session, you can access course page on my personal website, arifbud.me. The other way is to download all the notebooks from the course GitHub account, arifpucit, and all the notebooks for this course are housed in this public data science repository. Well, this is the Jupyter Notebook dashboard running locally on my machine at port 8888. And here is the notebook for lecture number 6.1 of the sixth module, overview of machine learning, for the course titled Tools and Techniques for Data Science. Well, today is the first session of this module in which I will try to set the stage right for our upcoming sessions. That will provide an overview of contemporary methods, techniques, and research topics within the field of machine learning. In simplest possible words, machine learning is the application of artificial intelligence that gives machines the ability to learn without being explicitly programmed. Well, this image at the top center describes the basic difference between conventional or traditional programming using simple if-else structure in languages like C, C++, Java, Python, and C#, and how to write machine learning programs using libraries like scikit-learn, PyTorch, Keras, and TensorFlow. Well, the left half of our screen right now shows different images of machine learning applications, while this right half shows the complete machine learning life cycle, which I have divided into 7 phases, namely understanding the business problem, data acquisition, data processing, exploratory data analysis, feature engineering, machine learning model creation, training, and evaluation. And remember, this training and evaluation are more related to supervised machine learning. And finally, we have to deploy the machine learning application to be accessible to the human users or to other programs. And don't worry, we will discuss and understand all these buzzwords in detail in today's session. So let us move on to the agenda of today's session. Well, so we will start with how machine learning fits in under the umbrella of AI. Then we will have a detailed discussion of the 3 questions: why to do machine learning, what is machine learning and its types, and how to do machine learning. And at the end, I will try to describe the tools and techniques involved in the overall machine learning development life cycle. This will be a theoretical session, but will cover very important concepts that are a must to understand before we make our hands dirty in doing machine learning. My dear students, let us start with this big picture, having artificial intelligence at the very top. The term AI, or artificial intelligence, was coined in 1950s. Actually, AI is the intelligence demonstrated by machines to sense, act, reason, and adapt like humans. However, with all the efforts, AI couldn't solve even the XOR problem in the 1990s. So all the fundings on AI were stopped at that time. Later, I think some professors of some universities at that time coined a new name for AI to get the funding, and the new name was machine learning. So instead of trying to make human like machines, they started trying to make a framework that can make better machines. So we can say that machine learning is a subset of AI that gives machines the ability to learn without being explicitly programmed. By this, I mean you don't write programs in languages like C++ and Java to implement your logic using selection and repetition structures. Rather, machine learning is a study of statistical computer algorithms that improve automatically through experience or maybe availability of more data. Don't worry, I will explain this more in the upcoming sections of today's video. Well, later in 2010, the term deep learning was coined, which is a subfield of machine learning and attempts to mimic the human brain. In simple words, the task that we do in machine learning using statistical methods, if we implement the same using multi-layer neural network, then we call it deep learning. Another major difference between machine learning and deep learning is that in machine learning, you do feature extraction yourself to be fed to the machine learning model. While in case of deep learning, the feature engineering is done automatically. Okay, so now let us fit in natural language processing in this bigger picture. My dear students, although the concept of natural language processing is quite old, however, the machine and deep learning techniques gave this domain an exponential boost. So, if you are using machine and deep learning models in order to enable machines to understand and respond to human languages, that means you are working in the domain of NLP and deep NLP, respectively. And finally, the term data science overlaps AI, ML, DL, and NLP. In simple words, data science is all about using large volumes of data to make business decisions. And formally, we can define data science as an interdisciplinary field that uses scientific methods, processes, algorithms, and systems to extract knowledge and insights from structured and unstructured data related to business problems. My dear students, the role of data scientist and machine learning engineer are quite overlapping. So, if you are a data scientist, you need to know machine learning, and if you are a machine learning engineer, you need to know data science. And finally, since data science is all about this big data, which is a combination of structured, semi structured, and unstructured data collected by organizations, which can be mined for information and used in machine learning projects. And later, the data scientists, perform predictive modeling and other advanced analytics applications. And I think in our initial sessions, we have also talked about the three V's of big data in detail, that is, volume, velocity, and variety. My dear students, this sixth module of our course is mainly concerned about machine learning. And before we start our discussion on what is machine learning and how to do machine learning, let us first have a quick review of different applications of machine learning. Okay, so these days you name a domain, be it a business domain, a government organization, a defense setup of a country, they all are using machine learning and data science one way or the other. Uh, the domains that are mentioned over here, they are in no specific order, but let me start with social media at number one. Let me talk about the use of machine learning in social media domain, which every one of us use for a reasonable number of hours every day. Over here, the first is the recommendation systems. My dear students, while using social networking sites like Facebook, Twitter, and LinkedIn, you all must have observed the feature people you may know, suggesting you who do you need to follow. These companies use machine learning algorithms to look at your profiles, the place you belong to, your interest, your current friends, their friends, and a whole bunch of other variables to make these recommendations. Similarly, while watching movies on Netflix, you might also have observed their recommendation system, which recommends you to watch a particular movie based on your viewing history, how long you have watched different titles, the movie categories, the actors, and maybe your age and gender. All these pieces of data are used as inputs to machine learning algorithms for this decision making and the design of these recommendation systems. So after recommendation systems, we have ad placement. Based on your on user data, these companies show you personalized advertisements that help optimizing the revenue of these companies. And my dear students, so we can use machine learning algorithms to perform sentiment analysis and opinion mining based on comments made by users of Facebook and tweets made by Twitter users of different regions of the world. And finally, on social media, another common application of machine learning is email spam and ham classification that we all have observed while using the Google Gmail product. Okay, my dear friends, machine learning is also heavily used in the domain of banking to perform tasks like uh, credit scoring, fraud detection, anti-money laundering, and price optimization. At number three, we have on the top right, this image shows the e-commerce domain, which is also heavily dependent on machine learning to offer different services to their customers, like uh, recommending right products to their customers based on their purchase history, encouraging customers for upselling and cross-selling, offering discounts on appropriate products on specific occasions throughout the year, and last but not least, forecasting demands of different items help these companies like Amazon, Flipkart, and Snapdeal to manage their inventories. At number four, in the bottom right, you can see different search engines like Google, Yahoo, Bing, and Baidu, which use machine learning to power their search algorithms, personalize search results, and ad placement strategies. Let us see some more applications of machine learning. While traveling, my dear students, on maybe Uber, Cream, Lyft, or Ola, you might have observed their dynamic pricing feature, which adjusts the price depending on features like weather and traffic conditions, location, time of the day, and overall customer demands. Different airlines use machine learning to predict flight delays, and we all have used the best route selection service of Google Map while traveling from point A to point B. At number six, in the bottom left of this image, you can see the applications of machine learning in the healthcare domain. It is used to diagnose diseases in patients from the X-rays, ultrasound, and MRI scans. Similarly, different variables like Fitbit watches track the blood pressure, heart rate, sugar level, and based on the current health data of the person, the system may trigger an alarm somewhere. And this Seeing AI, this is an application designed by Microsoft for people having vision impairment. The application sees the world through the camera of a smartphone and tells in real time to the person in his ears what is in front of him. At number 7, on the top right, we have automation. Machine learning is playing its role in automating different processes of manufacturing industries. You might have seen robot arms, which are a replacement of human labor. And moreover, due to the possibility of real-time processing of video data and performing object detection, classification, and tracking, the self-driving cars are no more a dream in 2022. Finally, my dear students, the credit and insurance companies are also using machine learning to detect frauds and perform claim prediction to reduce their financial losses. Okay, so after this brief and quick discussion on different application areas of machine learning, the one conclusion that we can make is that every famous computer application or service is using the machine learning techniques one way or the other. So, in order to eat the fruits of machine learning, you have to learn machine learning. So, let's do it. Okay, so I think I have answered the why part of the question. That is, why on God's earth we need to do machine learning. Now, let me answer the second question, and that is, what is machine learning? As already said, it is an application area of AI that gives machines the ability to learn without being explicitly programmed. Let me describe a bit this part of the definition that says without being explicitly programmed. Actually, in machine learning, we need to know about different ways of thinking about the input data so that we can identify the hidden patterns inside the data. So, in machine learning, you don't write programs, rather, you write algorithms, also known as models, which learn from the input data and generate maybe a mathematical function that is later used to predict. So, let us start with the two main types of this learning from your data, and these are uh, supervised machine learning, which actually is task driven, and unsupervised machine learning, which is actually data driven. Uh, in these video sessions of ours, we will be mainly discussing, understanding, and implementing these two categories. However, in literature, you may come across a third category of machine learning, and that is reinforcement learning, which is actually learning from errors or mistakes. In reinforcement learning, there is an agent which is exposed to a specific context or environment, and it performs certain actions and receives awards for its right actions and penalties for its wrong actions. And this is how we train the living beings as well. Maybe there are children, or maybe you are used to of having pets at your home, and you might have trained your pets the same way. And the application of reinforcement learning is mostly in game playing and robotics. So let us start with supervised machine learning. Let me describe it with the help of this diagram. Suppose we have a labeled data set, and there are, let's suppose, 20 data points, and each data point are actually features representing either a triangle, a circle, or a hexagon. The first thing we do in supervised machine learning is split the data into two parts, a training data set and a test data set, which are shown over here. This is the training data set and this is the test data set. So we have a total of 20 data points probably. I have kept 18 data points in the training data set to train the model, and 2 data points in the test data set to do the prediction on the trained model. So to our supervised machine learning model, we give the features as well as the uh, labels as input in order to train it. And during the training phase, the model learns the relationship between the input features and the output labels. And once the model is trained, which is of course going to take a bit of time, depending on your data set, we give the input features only to it, and it carry out the prediction as shown over here. And later, of course, we evaluate our model using different evaluation metrics to check the performance of our trained model. My dear students, once you get an accuracy for this specific split of training and testing data, you do a random split again and train, test, and evaluate your model on that. And you repeat this process many a times and keep track of the model accuracy as a function of these random trials. And this is what is known as cross validation, which is a solution to a problem called overfitting. My dear friends, don't worry, we will, inshallah, practically do all these tasks in our upcoming sessions. Okay, now let me tell you the two categories of supervised machine learning. One is known as the classification, and the other is known as the regression. Simply speaking, if your output label is categorized variable or categorical variable, for example, in this case of triangle, circle, and hexagon, or maybe in case of this figure, we have cold and hot, we call it a classification problem. Other examples of classification can be an email being spam or ham, a bank transaction being fraudulent or not. On the contrary, if the output label is a variable having a real value, for example, the temperature in degrees Fahrenheit, as shown in this right bottom image, we call it a regression problem. Other examples of regression can be house price prediction, stock price distance, and maybe CGPA prediction. I think enough about supervised machine learning. Let us now talk about unsupervised machine learning. Well, my dear friends, like supervised machine learning, the unsupervised machine learning can also be divided into two categories. If the output are discrete values or categories, it is called clustering. And if the output are real values, it is called association. And let me describe the clustering first with the help of this image. The first thing you might have observed from this diagram is that we have unlabeled data. We have roughly 16 objects or data points which are not labeled. That is, we cannot tell the learning algorithm what type of data it is. The goal of the algorithm itself is to discover the patterns in this data set without you being the architect of the discovery process. Okay, so now let us look at this input dataset. If I ask you to cluster this dataset containing different objects based on their commonalities, can you do that? So first of all, by looking at this box having different images over here, you can easily make out that these all objects are living beings. Next, you can make out that there is a category of objects which are human beings, and a category of dogs, and there is another category of fish. You may also be able to figure out the male and female category from this cluster of human beings. However, with the given information, at least I cannot further classify these dogs as well as the fish category as male and female. And this is what is shown over here in the output. The unsupervised clustering machine learning algorithm has been given this unlabeled input data set and it has classified excuse me, it has classified or clustered these objects into into three sets: a set of dogs, fish, and human beings. So unsupervised learning is mainly about finding clusters in your given data set and maybe answer questions like how many clusters are there. In our case, we have identified three. How big each cluster is, how cohesive these clusters are, uh, is there any outlier, or is there a hierarchy that exists in these clusters, and so on. Okay, so after having an overview of clustering, let's now talk about the second category of unsupervised machine learning, and that is association. My dear students, association is actually understanding how certain data features connect with other features. If you have ever done any online shopping, you must have seen recommendation pop ups saying things like people who purchased this and that also purchased this and that, and so on. These suggestions are the result of market basket analysis aimed at identifying frequent shopping habits of customers with the goal of increasing the sales of the company. In physical stores as well, such analysis provides suggestions on how to place products on the shelves to mutually promote their purchase. In addition to market basket analysis, association rule mining can also be used for stock analysis, social network analysis, web log mining, medical diagnosis, and bioinformatics. Hmm. So over here in this figure from this input data set, the algorithm has find out that the bread and the butter, these are the two items which are mostly purchased. That is, if anybody has bought bread, he or she has also bought butter, and vice versa. Great job done. Okay, fine. My dear students, I have answered the why and the what question at an abstract level. Let me now answer the how question again at an abstract level. And this image lists down different use cases, algorithms, and evaluation techniques for both the classification as well as the regression algorithms. We will understand the math as well as we will inshallah practically implement some of these supervised machine learning algorithms in our upcoming sessions. Uh, these ensemble methods mentioned at the very end actually combine the predictive power of some of these base estimators. Uh, Gradient boosting and ADA boosting are some examples of ensemble learning algorithms. Please spend some time and increase your vocabulary by by reading out all these algorithm names and evaluation techniques. And of course, inshallah, we will cover them in detail. Similarly, here is the list of different use cases and algorithms for clustering and association. My dear friends, for the time being, I'm just giving you a bigger picture, just trying to increase your vocabulary. Don't worry. Once you are done with the videos of this module, I assure that this will not be all Greek for you, inshallah. Okay, so here is the final part, and that is the complete life cycle of a machine learning project. I have divided it into 7 phases. In literature, you may come across more or less phases depending on the task performed in each phase. Anyway, the 7 phases right now, which we are going to discuss, are uh, business problem understanding, data acquisition, data cleaning, or data processing, exploratory data analysis and visualization, feature engineering, machine learning model creation, training and evaluation, and Finally, we have the deployment and monitoring phase of the project. My dear students, although in this module of machine learning, we are mainly concerned about a thorough discussion on uh, actually uh, uh, different supervised and unsupervised machine learning models, their evaluation techniques, and uh, since a machine learning model is never a standalone application, uh, rather is always a part of a bigger application. So I think it appropriate to give a bit of time on all of these phases to make you understand as to how a machine learning model that we will be creating and evaluating in this phase uh, will fit into an app having a web or a mobile interface. So let us discuss these phases one by one. Uh, okay. My dear friends, design of every machine learning application always starts with understanding the problem at hand. And of course, this is the most critical phase of every machine learning project. And if it is conducted well, excuse me, will save a lot of time, money, and resources. In order to have a clear understanding of the problem, you may have to talk to the stakeholders and domain experts in order to get answers to a lot of why questions. In this process, you have to identify the key business variables that need to be predicted and define the success criteria and success measuring metrics. My dear students, in big companies, this phase is normally the baby of the project manager and not the machine learning engineer normally. Well, after the problem is clearly understood, the next phase is the data acquisition. This phase is all about retrieving and consolidating all the data from multiple sources like web servers, logs, databases, web APIs, and online repositories. My dear students, once again, in big companies, this phase is the baby of data engineer and not the machine learning engineer. In this module of ours, we will be using the built-in toy datasets available in libraries like Seaborn, Scikit-learn, or NLTK. Maybe we will explore some real-world datasets from some public dataset repository like uh, Kaggle, GitHub, and the UCI machine learning repository. Interested students can go through the web scraping module of this course where I have used Beautiful Soup, Selenium, and Scrapy libraries to scrape data from different websites. The link is given over here. However, if you are collecting such data which is unlabeled, you may have to put in efforts to label it manually or using some crowdsourcing services like Amazon Turk or LineBridge AI. And finally, the importance of this data acquisition phase can be understood with this statement, and that is better data often beats better algorithms. Okay, my dear students, once we have acquired the data, we need to process it so that it can be later fed to a machine learning algorithm. We have seen this in our pandas videos where we discuss different techniques to remove the duplicates, handle the missing values, and the outliers as well. In big companies, excuse me, uh, in big companies, data processing is actually a part of an ETL pipeline, extract, transform, load, uh, which is done for batch as well as for real time data processing. Once again, the data engineer is responsible for extracting the data maybe from multiple heterogeneous sources in the extract phase. Then he or she has to do data cleansing and wrangling before he loads the transformed data into maybe data warehouse from where it is further loaded into maybe a pandas data frame for later analysis. So in simple words, data acquisition and data processing can be combined into a ETL pipeline whose output is the cleaned data on which EDA can be performed. So let's move on to the next phase, and that is of course EDA and visualization. So once you have the cleaned data, you do exploratory data analysis on it and try to find out the relationships between various input columns and maybe the output column or label. And for this, you perform a univariate analysis. To measure the central tendency, you use mean, median, and mode. To measure the spread, you use a range, IQR, variance, and standard deviation. And to measure the maybe asymmetry, you use skewness and kurtosis. And similarly, to see the relationship between multiple variables or features of your dataset, you use covariance and correlation. And I think this we have covered in detail in our module 4 while discussing the descriptive and inferential statistics, whose video links are shown over here. My dear students, a picture is worth 1,000 words. So in order to visualize all these patterns hidden in the dataset, we have used Matplotlib, Seaborn, and Plotly libraries in 5 video sessions of module 3. Okay, so let's move ahead and move on to the next phase, and that is feature engineering. My dear students, once we have the complete understanding of different input features and their relationship with each other, as well as with the output column or label, it is time to do the feature engineering. Formally speaking, feature engineering is the process of using domain knowledge to extract features from raw data via data mining techniques. In general, there are 3 approaches to feature engineering: extracting information, combining information, and transforming information. Let me describe these with the help of a sample housing dataset having 8 input features and the output label named price. Let us first understand what do we mean by extracting information. Consider this column construction date of the house that has a timestamp for each row. In its current format, it is very difficult to pass this feature to a machine learning algorithm. In linear regression algorithm, the model tries to multiply this value with a numeric coefficient, which is not possible. In general, most machine learning algorithms expect the value of these features to be integer or real numbers. So we need to extract the information from this date time stamp. So one way is to extract the year, month, and date information, and instead of one column construction date, we can have 3 columns like year, month, and day of the month. So this is one example of extracting information from existing columns. The second approach to feature engineering is combining information. And this can be done by merging multiple columns to lesser number of columns. And this is shown over here, where the 3 input features in the dataset, like the size of the house, the number of bedrooms and bathrooms, are reduced to a single size feature. You can see it over here. Similarly, the schools around and the park around, let's suppose, these 2 features can be combined to one feature, that is location feature. And of course, we have discussed this as well in detail in our video lecture number 4.4, while studying the principal component analysis, which is an algorithm for dimensionality reduction. And the video link is also shown over here. Okay, after merging or combining, the third is transforming information. Well, this is again a very common for string data. Consider this city column over here having categorical values like Lahore, Karachi, Islamabad, and Sheikhupura. Once again, machine learning algorithms cannot accept string data as you cannot multiply a string such as Lahore by a numeric coefficient. The two basic approaches that can be used over here are integer encoding and one-hot encoding, also known as creating dummy variables. And this also we have done in our pandas video. Well, anyway, let me give a quick recap. In integer encoding, we simply assign an integer value to every city. For example, in this case, 1 to Lahore, 2 to Karachi, 3 to Islamabad, and 4 to Sheikhupura. The integer encoding, however, has an issue, and that is giving more weight to Sheikhupura by assigning it a value of 4. Uh, it may not later produce good results. So, this integer encoding technique is better suited for ordinal variables. Ordinal variables having values like small, medium, large, and so on. So, to transform this city column, a better encoding scheme is one hot encoding. Let us suppose that we have just uh, four possible cities under this column. So we will create a new column or feature for every single unique category possible. So in this particular case, the city column is transformed to four columns with the name of the four cities and with the one under the column of that city and zero elsewhere. And this is why they are called dummy variables, because these are not actual variables that were present in the data. I think I have gone into too much of detail of feature engineering, which we have covered in our previous videos as well. And inshallah, I will discuss more about this topic in our next module of natural language processing as well. So let us move ahead to phase 6. Okay. Well, my dear friends, this is the phase where we will be spending much of our time in our upcoming video sessions of this machine learning module. I have further divided this phase into 5 steps. First is the machine learning model selection, where we will select an appropriate algorithm to solve the problem at hand depending on the available dataset. We will, of course, understand the math involved uh, in this model. We will do the hyperparameter tuning, which in simple words is actually like adjusting the knobs of a microwave oven to cook your favorite dish. The third step is to train the model. The fourth step is to carry out the prediction. And finally, we perform model evaluation and do cross validation as well. And let me quickly describe these steps at an abstract level uh, using these two data sets shown in two tables. Please note that both these tables have four input features of patients having height, weight, blood pressure systolic, and blood pressure diastolic, all having numeric values. The output or label column in this left table is heart disease, having two categorical values, yes or no, specifying if the patient with that record suffers from heart disease or not. And my dear students, since the output label has categorical values, so the data in this left table is a classification problem. We need to classify if a patient has a heart disease or not. Now, if you see the table on the right, the input features are same, but the output or the label column is cholesterol level having real values. So this is a regression problem. Moreover, since we have a labeled data set in both of these tables, so the problem can be solved using some supervised machine learning algorithm. In both these tables, we have nine records. We have nine records or data points with their corresponding output labels. We have to divide the given dataset in two parts. This blue box over here having seven data points is the training dataset, while these two rows or records or data points shown in the purple box is the test dataset. The training dataset is further divided into two parts, X and Y. Uh, X is actually a matrix, this one, of size 7 by 4, while this Y is a vector of output labels of size 7 into 1. I hope this is clear to you. Uh, this black box, this rectangle like black box, is a single feature vector. Let's suppose this is x3 in this case, having four dimensions. The first dimension of this feature vector is having the value height of a specific patient. The second dimension is having the value of weight. The third dimension is having the value of BP systolic, and the fourth BP diastolic. Both X and Y are given to the model as input for training, and this is also shown formally over here in the bottom, where D is the dataset, X1 is a 4D vector of input feature, and Y1 is the corresponding output label. Similarly, X2, Y2, X3, Y3, and so on. Anyway, once the model is trained, these two last data points, only the input features, are given to the trained model so that it can predict the output, and that output is later compared with the known labels to actually verify its performance. And my dear friends, once uh, this is done for this split, that is 1 to 7 for the training set and 8 9 for the test set, we do the cross validation as well. And maybe we may also need to do some hyperparameter tuning in order to improve the results. And don't worry much, as in our next videos we are going to perform all these steps practically on different classification and regression algorithms using different datasets, inshallah. Okay. My dear students, once you have trained and evaluated your model, the final step is to place your machine learning model into a live environment from where it can be accessed by end users or maybe by some application through an API. So the first thing you do is serialize the model object using Python pickle or job-lib module. Then you create a web app using Flask or Django or any other framework of your choice, and check the working of the app on your local machine. Once satisfied, uh, you can use any cloud service of your choice like AWS EC2 to deploy your app. The end users can then access the service using a web or a mobile front end application. My dear friends, once your model is deployed, the last thing you need to do is continuously perform monitoring of your model, and may like to retrain it on the new incoming data based on its performance. And this can be done in two ways. One is known as batch machine learning, which is done in the development environment, and the other is known as online machine learning, which is done in the production environment, that is on the live server in an incremental fashion. If you don't do this, your model will become obsolete with time. So you retrain your model on maybe daily, weekly, or monthly basis. In case of batch machine learning, you pull down your model from server, retrain it, and then push it on the server periodically. And in case of online machine learning, the model training is done on the server incrementally. That is, instead to uh, you use the fit method, you use partial fit method to train your model on the partial data. Well, I think enough of discussion on deployment and monitoring. Well, that is all for today's session. I hope now you have a fair idea of the bigger picture of the domain of machine learning, its types, and the overall machine learning development lifecycle. In the upcoming sessions of this module, we will concentrate, of course, on phase 6. And in each session, inshallah, we will learn the math behind a specific supervised or unsupervised machine learning algorithm, create the model using sklearn library, and then train, predict, and evaluate that model. My dear students, if you have liked this video, please subscribe my YouTube channel and share it with your friends. I wish you all the best, happy learning, and Allah Hafiz.